Welcome to this explainer. Today, we're setting the stage for a really interesting journey into the escalating layers of network defense. We're going to unpack exactly how modern FortiGate firewalls manage identity and secure your network. Let's get right into it. Think about this for a second. If an IP address accesses your network, do you actually know who is behind the keyboard? Historically, firewalls acted kind of like a castle moat, right? They'd granted access based solely on a source IP address or a recognized device. But here's the glaring problem with that. An IP address does not equal human identity. If a device gets compromised, or honestly, if a user just walks away to grab a coffee, the firewall has zero idea who is actually sitting at that keyboard. It's a massive security risk. To fix this, we've got a clear roadmap for this explainer. We'll go beyond IP addresses, compare local and server-based authentication, break down LDAP and RADIUS, explore the power of two-factor, look at active versus passive authentication, and finally, enforce firewall policies. Section 1. Beyond IP addresses. Let's think of the FortiGate firewall not just as a brick wall, but as a highly intelligent nightclub bouncer whose main job is rigorously checking IDs. FortiGate fundamentally shifts the security paradigm. Instead of just waving a recognized laptop through the door, it demands valid user credentials, a username and password. Once our FortiGate bouncer accurately identifies the individual person or the user group they belong to, only then does it apply specific firewall policies. This is huge because it allows organizations to track actual individuals across multiple devices, deciding exactly what resources they are allowed to access or absolutely denied from seeing. Section 2. Local versus server-based authentication. Let's see how this builds from a baseline fix into a full-scale enterprise-ready solution. So we have two main approaches here. Local authentication is the simplest method. The usernames and passwords are created and stored right there on the physical or virtual FortiGate device itself. This is fantastic if you just have a single installation. But let's say you have a massive network with multiple firewalls. You definitely don't want to recreate those user accounts over and over again. That's where server-based or remote authentication comes in. The crucial distinction here is that with server-based authentication, the FortiGate bouncer doesn't actually evaluate the passwords itself. It just takes the credentials, securely asks the remote server if they're valid, and then manages the traffic based on the server's thumbs up or thumbs down. Section 3. LDAP and RADIUS explained. So, what exactly are those remote registries we just talked about? Let's take a look. What's really fascinating here is how LDAP, the Lightweight Directory Access Protocol, perfectly mirrors a real-world organization's framework. It uses a hierarchical tree structure. At the very top, you have the root, representing the domain component, like your company's web address. Right beneath that, you organize your data into organizational units, basically representing different departments. And finally, you get down to the individual users, identified by their user ID. When FortiGate queries an LDAP server, it requires the specific path, known as the distinguished name, to pinpoint exactly where that user lives in the tree. Now, RADIUS operates quite differently. It doesn't use a directory tree at all. Instead, it's a standard protocol specifically built for providing authentication, authorization, and accounting, or AAA services. When the FortiGate client sends over an access request packet, the RADIUS server evaluates it and sends back one of three replies. It can send an access accept, an access reject, or, very interestingly, an access challenge. This challenge basically means the server needs more information, which leads us perfectly into our next major topic. Section 4. The power of two-factor. We need to introduce the next major vulnerability facing networks today, stolen static passwords, and how we actually defend against that threat. It all boils down to this golden rule, something you know and something you have. Let's face it, relying on static passwords alone is a fundamentally weak method of security. People reuse passwords across vulnerable websites all the time. If an attacker gets your username, guessing or stealing the password is literally the only barrier left. Two-factor authentication, or 2FA, actively defends against this by demanding a secondary physical token or certificate. This drastically increases the complexity for any attacker trying to compromise an account. There's just no way around it. FortiGate handles this using one-time passwords, or OTPs for that second factor. And network administrators have some amazing flexibility in how they deliver these codes. You can use a FortiToken 200, which is a physical hard token. You can use FortiToken Mobile, an app that even supports push approvals so you don't even have to type a code. Or, if the user account has contact info configured, you can just send the OTP via email or SMS. It's all about putting that highly secure second factor right into the user's hand. So, how does a token magically generate a valid 60-second passcode without an internet connection? It uses two inputs, a static, randomly generated seed value and the current time from an internal clock. An algorithm processes these two inputs to generate the passcode. When the user submits it, the validation server, our FortiGate, uses its own copy of the exact same seed and its own system time to recalculate the algorithm. If both answers match, boom, access granted. Because this is strictly time-based, having an accurate NTP server to keep the clocks perfectly synchronized is absolutely crucial. Section 5. Active versus passive authentication. Now, let's shift our focus to how the firewall's brain processes these authentication attempts behind the scenes to keep things smooth for the user. Imagine managing a massive enterprise. If you used active authentication for everything, your users would constantly be hit with manual login prompts every single time they opened a new browser tab. It requires them to manually enter credentials. It's a hassle. But with passive authentication, access is granted completely transparently. The FortiGate determines the user's identity silently, behind the scenes, using single sign-on methods like FSO. The user never even sees a prompt, but the firewall still securely verifies exactly who they are. Now, when active authentication is required, there are some strict protocol rules to be aware of. To even show a user that captive portal login dialog, the firewall policy has to explicitly allow protocols that can carry that prompt, specifically HTTP, HTTPS, FTP, or Telnet. If you block all of these, your users will never see the login screen, and authentication will just flat out fail. Also, quick tip, DNS must explicitly be allowed pre-authentication. Otherwise, the user's computer can't even resolve host names to trigger those protocols in the first place. Section 6. Enforcing firewall policies. Let's bring our journey to its culmination by looking at how the bouncer actually writes and enforces the rulebook. A firewall policy consists of compartmentalized instruction sets. When you define the source of the traffic, you don't just put the local subnet IP address anymore. You literally attach the actual user or user group object right next to it. FortiGate evaluates the traffic, sees that authentication is required for that source, and springs into action to accept or deny the communication session based strictly on human identity. Finally, we've got to briefly reiterate how timeouts act as a final, critical layer of defense. If an authenticated user walks away from their desk, we can't just leave that connection open forever. FortiGate uses three behaviors. Idle logs them out if no packets are generated. Hard logs them out after a strict absolute time limit regardless of activity. And new session logs them out if they don't create any new connections through the firewall, even if they are still downloading a huge file. This prevents unauthorized IP use and keeps the firewall's memories super clean. Which brings us to the end of our explainer, but I want to leave you with this provocative thought regarding your own network security posture. Is your firewall merely guarding recognized devices, or is it intelligently verifying the actual people behind them? By leveraging local and remote authentication, enforcing strict two-factor protocols, and tying identity directly to your firewall policies, you completely take back control of your network. Thank you so much for learning with me today, and I hope this leaves you eager to go out and optimize your own firewall rules.